Hey guys, how's it going? Alright, so I'm not going to do every problem from this review sheet. If you didn't notice, it says that it is a mock summative. So basically, essentially what this means is that the information that's on the front and back of your homework for this weekend is essentially going to look a lot like the last two pages, or the last front and back page of your assessment. So please take this seriously when you're doing it, okay? Function notation. Some of you guys are doing very well with it. Some people are having some difficulties. Hopefully by looking at this video, we'll be able to clear some things up as extra practice, okay? We didn't get into teaching you what an interval was yet. So I asked you guys to cross that out, and hopefully you are able to figure out which one is increasing from class. We kind of did it. If you're not able to, increasing means it's going up, right, in values. So this graph is clearly not only going up. It does increase, like from here to here, but it also decreases, right? These f of x values on the table, 20, 10, 8, 0, is clearly going down, so that isn't it. This is your answer for number 1. The h of x equals 5 to the x power. And that's because if you were to make a table for this, forgive me, I'm going fast, so it's not going to be neat. And you had, like, these are your x values, 1, 2, 3, 4. That's going to be 5 to the first power. This is going to be 5 to the second power, because x has to be the same according to this equation. 5 to the third, 5 to the fourth. And yeah, it's going to get bigger. Some people during class said, what if you start with a negative exponent? You can do that. 5 to the negative fourth, 5 to the negative third. It's still going to eventually get bigger, right? Or it's getting bigger the whole time, really. Okay. Now I'm going to move on to number 2 while I'm erasing this. Identify the y-intercept of each of the following. If you haven't been able to catch it up yet, the y-intercept, or any y-intercept, it's when x equals 0 for that graph. X equals 0, and it's a lot easier to see it with the graph. X equals 0 on this whole y-axis, right? And we've already discussed that it doesn't matter where, oh, that's way too big. It doesn't matter where the dot is, right? If it's on the y-axis, it's a y-intercept, which it says right here. So once again, at any y-intercept, x equals 0. So using that, let's think about it. The first one says f of x. So you go to this table, find where x equals 0, which is right here, and the f of x value, or the y value, right, is 0. So that's the y-intercept for that one. It just happened to also be 0, okay? The graph, you guys are really good at looking at that. What's the y-intercept? You go up and down on this y-axis until you find it, and it's right here. And that value would be 6, okay? Now h of x would be slightly more trickier, but hopefully we were able to get it. Once again, x is 0, so if you were to put in a 0 for this x, according to this exponential equation right above me, it'd be 5 to the 0 power, right? And we could simplify that because we know anything to the 0 power equals 1, right? So this is 1. And then hopefully you're able to answer number 3 after I just went over that with you. Okay, that's pretty easy. Which one has the smallest value? Just circle it. Or I'm sorry, rewrite it over here. Okay. I'm going to erase all that. Bam! Now number 4, which has the greatest value? For these, you have to remember that x used to be inside of these parentheses, right? H of x, g of x, f of x. You can look up there if you ever forget. Okay? So for this f, it says x is 7. So I'm going to go down to where x is 7. And the answer is negative 14. If you were to write this out, it would be f of 7 equals negative 14. So that's negative 14 for f of 7. I'll use different colors to help you guys track it. G of negative 2, since it's G, I'm going to look at the graph, right? And it says where x is negative 2. So I'm going to go on my x to negative 2, which is here. And you go down, there's nothing down there, or up until you hit the graph. And remember, I'm still on the negative 2. So here you go, and your answer is 5. That is the y value for that. Okay? And this one, the last one, we actually just did this up there because I said x is 0 for any y-intercept, and the answer is 1. And if you forgot, it's because I said it would have been 5 to the 0 power because this x is 0. Okay? So hopefully this front page of the function notation, or the first 4 questions, aren't too bad. I wanted to move on to this. A lot of you guys have been doing well with it, but just in case if you've forgotten, don't get tricked up just because they put different letters in here. Okay? What used to be in there was still x. Right? So what this is saying is, and I'll go one by one, f of q equals 20, aka f of some number, some x value, right? Because x used to be in there, equals 20. So you look in this f category, this column, f of some number equals 20. You see a 20 right here. So that must mean that f of negative 10 would equal 20. So the first one would be that q equals negative 10. Once again, because of this matching value in the table. Alright, g of something, and I know my g's are up and down, right? X's are side to side, but g's are up and down. So once again, g of some number, which is supposed to be r, I guess, equals 6. So let's go up until we hit 6 on this g axis. And we've actually got it pretty easy. It's right here. And the x value right there is 0 because it's a y-intercept. It hits it right on the money right there. Okay? And the last one, h of something equals 125. So I'm going to just write this s. In order to figure that out, you've got to match it up with this 5 to the x power. Some of you guys are a lot better if we take it back to the last topic of exponents, right? So instead of h of x, we could write 5 to the x power. It's the same exact thing. So you could just rewrite this as 5 to the x equals 125. Clearly your base is 5 in this problem, so let's break it down. 5, 25. Keep breaking that 25 down because you have to. And then you're going to end up rewriting this whole exponential equation that we're working on right now as 5 to the x power, because I haven't done anything with the left, equals 1, 2, 3, 5 to the third power. Okay? So that x would have been 3. And since they rewrote this x and put an s in there, s is the same thing, right? So like, this is going to look weird, but s equals x, which also equals 3, so s could also equal 3, right? So those are your answers. And don't forget to do this part. What value is q plus r plus s? You would just add negative 10 plus 0 plus 3, okay? I'm not going to do that because I know you guys are more than capable of adding. This was the vertical line test that we taught you guys. If you draw a line straight up and down or whatever, if you draw a vertical line, right, and it hits your graph only once, it passes, and it is a function. If it hits it more than once, it fails, and it is not a function. We actually did these exact 2 in class. I'm not going to give you the answers to those. Hopefully just having the reminder of drawing this vertical line at random parts of the graph, right? Like draw one here, another one, there isn't an exact perfect place to put it, but just make a bunch of vertical lines. I'd say like 4 in different parts of your graph and see how many times it hits it. If any one of the lines that you draw hits this graph when you draw the vertical line test more than once, it fails and is not a function. Okay? And let me get to this number of nenes example. I briefly touched on this, but I didn't get to spend too much time on it because of time. Alright, so the number of nenes on the dance floor is the function of time. So this is what I was talking about before. When you read this equation, right? The number of nenes is a function of, or depends on, how many hours are passing, right? And they give you this equation to use for it. Okay? So, let's get right into it. Number 9. It says n of 4 equals what? They took this h out and put a 4. So, whatever this is going to become, this has to change also, because they're the same letter. So you would literally rewrite this 100 times 5 to the 4th power, because you have to make, let me make the colors match, this and this match because they match here. Okay, and then put that in your calculator, see what it gives you. It's going to be some big number, 100 times 5 to the 4th power. When you write this, what does n of 4 mean? We also briefly touched on that in class, and I actually just talked about it when I was up here talking about the equation. After 4 hours, because that's what's inside the parentheses, there would have been blank nays on the dance floor. Okay. So once again, the number of nenes depends on how many hours there are of this dance, right? The bigger the number is in here, the bigger the number of nenes would be. I didn't write this number in because I'm hoping you could put that in the calculator and figure out what number matches up for these, okay? Now this part is going back to solving equations. Let me just move some things around because we're going to need a little space. Alright, so the party has to shut down when there is 312,500 nenes on the dance floor. I guess they can't take the nene, which is represented by the function n of h equals 312,500. At what time did the party shut down? Alright, take this number of nenes, right? See how it's a big number? And bring it back to this equation. If n of h equals this, 312,500, but up here they also told us in the equation n of h equals this, literally you could rewrite, you could take these nh's out and just like set that equal to this. So I'm going to do that right now. So let me clear this. 100. So you just set it up. 100 times 5 to the h, 5 to the h power equals this big number, 312,500. Okay? So I hope you're following me, guys. All I did was I got this from the n of h example, right? Alright, so right now what we're doing is we're taking it back old school to what we've been doing a lot of the time, and we're solving for the variable. So look for the number that is the easiest to get rid of on this side, and that would be this 100. This 5 has some parentheses, it's shielded away. We're eventually going to get to that, but right now let's get rid of that 100. You guys are really good at knowing that when the number is right next to another number and there's a parentheses between them, that there's really multiplication, right? So let's get rid of this 100. And the inverse is how you get rid of things in math, right? So you divide both sides by 100. Okay? What happens to these two 100s? They cancel. What's left on this left-hand side would be 5 to the h equals whatever 312,500 is, and you're going to have to divide that by 100. Okay? Oops, hold on. So, bam! If you also remember the trick with the zeros, you could just cancel those out. Okay? Sorry, I was doing something. Alright, so this 312,000 divided by 500, 312,500 divided by 100 gives you 3,125. Now, you're going to have to break it down with this base of 5 in order to get that exponent. Okay? We want both sides to be the same, or have the same base, sorry. So, we're going to break it down with the 5. That's going to give you 625. And then you just keep going. 625 divided by 5 is 125. 125 divided by 5 is 25. And 25 divided by 5 is 5. Okay? So right now we've got 1, 2, 3, 4, 5 5s. Okay? So essentially what I'm going to do right now is rewrite this 3,125 as 5 to the h power equals 5 to the 5th power, because there are 5 5s. After that, we've got common bases, so I really don't care about those anymore. You just set your exponents equal to each other, and there is your answer. The number of hours it would have taken is 5 hours. Okay. Hopefully this helped, guys. And if you have any further questions, you can always put a comment on it, email me, or ask me during class on Monday. Okay. Hope you guys have a great weekend. Okay. I know you're working hard. You've got a lot of stuff to do, and I appreciate all the work you're putting into this class. Take care, guys. Have a good weekend. Bye.